Hi, my name is Saul Montoya. This time we are going to do a tutorial about how to assess water consumption from forested areas and compare them to the water consumption from deforested areas. For this tutorial we are going to use two MODIS data products. The first one is this one that is called a land cover type yearly with a resolution of 500 meters. And the product name of this one is MCD12Q1, and the other image that we're going to use for this tutorial is the MODIS evapotranspiration datasets, that is the MOD16. So where do you download the MCD12Q1, that is the land cover raster? You download it from this server, that is the NASA EcoReverb, and there is a whole procedure to do that. In this tutorial we are not going to cover this. Maybe we have done in some former tutorials of our Hatariwater.tumblr.com if you are more interested. And to download the mod16 you have to use this address. I hope that it reads well on your screen, and otherwise on the video description the links will be there. And we have yearly the actual evapotranspiration, that is water consumption by plants. So the selected year is 2013, and let's see, we are looking for the H10V9. So the H10 is this one. So this is actually the image that we're going to use for 2013 because it belongs to the area what we're interested. In this case, you don't need, for this tutorial, you don't need to actually download the data because we have downloaded for you. On the description of this video, you will find the rasters where there is already the MC12, the land cover type, plus the evapotranspiration, the actual evapotranspiration. So we have both. There is no rush to. You don't have to do it to follow this tutorial. If you wanted to do it for your own area, maybe you will need it to download it. Okay. So we are going to, and plus you are going. There is a shape of the area of interest that is on geographical WGS84. Okay. So in a new QuantumGIS project, we open the two rasters. We open the two rasters, so that's in fact this and this. We open them, and for the land cover type we are going to use the type 3. The whole description of which layer is here, and there are every layer is an algorithm to represent the land cover. So if we go here to layers, we have type 1 is this algorithm, this one. In this case, I have done this before because I wanted to represent really deforested areas and really forested areas. And for this, deforested areas will be as savannas, so it will be as type 4, while the forested area will be evergreen broadleaf forests. So, and we are going to, our analysis will be mainly in these two land cover types. Okay, cool. So from mod16, from mod12Q1 we select land cover type 3, and for mode 17 we select actual evapotranspiration 1 kilometer. This is the resolution, because this is the potential evapotranspiration, this is the actual evapotranspiration, this is the quality control. So the first one. Okay, cool. For you that are new to QGIS, and maybe for me, there is some there is something that you have to do first in order to work with your rasters. That is that you have to, what you are seeing here is just a representation of the raster, but this is on a spatial reference, this system of reference coordinates that are not very compatible to do spatial analysis. So one of the first things that you have to do is to convert it to WGS in a T format or like a GRD format. Okay, first we are missing one more, that is the area of interest. This is in shape, area of interest, because our area of interest is just this part. So it's a part that is on the rainforest, on the Peruvian rainforest, where some part is deforested and the other part is actually forested, rainforest. Okay, so first we need to save both. This one, like we say right click and we say save as, and the only is we save as geotiff, and this is, for example, in raster we say evapotranspiration in WGS84, because it's actually I like to put the system, the coordinate system on the names. And just be careful of this, because if you go with these input values, actually it does do nothing. So we have to go with the resolution of the layer, with the layer resolution, and we do OK. Actually nothing has happened, just that we have the evapotranspiration as WGS. So if we want to check it, just do right click and they say see the system coordinates, and we are in WGS. Cool. We do the same for the land cover type, so we say save as. I'm sorry, my QGIS is in Spanish, so but I think that it's the same, around the same position, the commands. And we go to explore and we say is land cover WGS84. Cool. And again raster resolution or layer resolution, and we put it again. Okay, cool. So we have the land cover and the evapotranspiration. Actually, and my recommendation is that you do not need this data anymore. So just put right click and put eliminar, and then you do just right click and you put eliminate, because actually this is not data that will run on with the algorithms that we are going to use. So this is this reprojected data to geographical is the ones that we are going to use. Okay, cool. Then we have to cut the land cover to our area of interest. In order to cut the land, I will put this. I do zoom, and here we have, we have for our area of interest, I will take out the fill, I don't want fill on my polygon, and maybe I wanted some more. Okay, so mostly this is the deforested areas that are savannas, and these are the ones that are white are the forested areas. And there is some, I mean, the data product comes with another pixels of crops, lands, and so on. But our main interest is in deforested areas and forested areas. Okay, cool. What else? What you will we need to cut this, because our land cover raster is huge in order to do the analysis, and we will, if we have this whole area, we are going to do an area for a whole extension, and maybe this won't even be possible with QGIS. So in order to cut it, we go to raster, we go to extraction, and we say clipper. In clipper we go to the land cover, and then we select the output file that will be on shapes, and here in shapes will be land cover. Oh, no, sorry, it will be on rasters, because the output of this is on rasters, and it will be land, this one, but we will go with cut. Cool. And then we select the mask. The mask is actually our area of interest. Cool. So we have the land cover, that is our initial raster, this is our output raster, this is the mask, and nothing else. We just need this. Cool. And we wait. Okay, so here we don't need it anymore, and here we have just we have this as the raster file. Okay, the next step is actually to turn, in order to do zonal statistics, in order to analyze which is the water consumption for savannas and for forest, we need to transform this to polygons. So we do it polygonize, raster, conversion, polygonize, and we go with our cut. It's very important not to just to remind which is the raster that you are working with, because otherwise you will be selecting another raster, like maybe evapotranspiration, that we don't want the polygons of evapotranspiration, we want the polygons of land cover cut. And the shapefile, this will be on shapes, and this will be called land cover WGS84 cut. We put it this, and this is the field name. The field name will be type, because it's the type of land cover, and nothing else. We do like this. Okay, cool. Okay, we have at the output is a shapefile that actually has how many elements? Has 65 elements, and because it will calculate which is the water consumption for every pixel. But in fact we want to group this. I mean, we want that all the pixels that are forest will be as one big group. We want all the pixels that are savanna will be as another group. So therefore we needed to pass this from single parts to multiparts. So in order to do that, we go from vectorial, geometry, single parts to multipart, single parts to multipart. So we selected our not area of interest, the land cover cut, and with type, and we put the output shape as here cut, and we say m part, that is called multipart. Okay. Now we have a shapefile that actually has only 9 categories, while the other ones has it only has 9 objects, while the other one has 651. So what else we will do is just we will put right click, save. No, we can do some styles here, properties, categorize it, spectral. Our main interest is in between this one that is called the type number 4, that is 4 is savanna, 4 is this one, and the other one that is called number 5, that is evergreen broadleaf forest. And there is another one that is number 2, that is shrubs, or maybe number 1 that they are crops. Okay, so this is our main interest of study. Here in QAS we can do this. We can put some transparency. We will put a 50% of transparency because I want to show where are the forested areas, so deforested areas on web. If you don't have this open layers plugin, it's really easy to install it. You just go to plugins, install, and then you just type for plugins, and I will look for the Bing Maps area. So if you can see here, it's cool. Like if you see, so you have the deforested areas, and then you have the forested areas. Cool. There is good fit on this. Well, it's a data product, it's available for the whole planet, so I think it's okay for our analysis. Okay, cool. What else? Okay, then we have to, now here we have our multipart, and here we have our, we don't need this road, we have our evapotranspiration. So we are going to do a zonal statistics. So we go to raster, zonal statistics, and we are going to select the evapotranspiration with the multipart, and we want just the number and the media, because it can, the media and the median, because we don't want a whole set of minimum, maximum, so we want to say which is the average value and the median value. Okay, so, and the prefix, this is very important, so we are going to put this ET, so we put aceptar. Okay, and then we go here to our shapefile, we put attribute table, and then here we have okay, in order to put it more didactically, I'm going to add a new column. So I go to the editor, I will add a new column. The new column will be type cover type. No, it will be text, and it will have a 20 off. Okay, so cover type 0 is equal to water. Cover type 1 is equal to grasses. Cover type 2 is equal to shrubs. Cover type 3 is equal to broadleaf crops. Type 4 is equal to savanna. This is equal to evergreen crops. Bien. And then number 6, no, evergreen forest. And this is deciduous forest, that is temporary forest. Deciduous forest. 9 is equal to non-vegetated and urban. Non-vegetated and urban. Okay, first of all, we are going to see which is, this is the count, this is the pixel count, and we are going to see which is the most popular land cover type. So our most popular land cover type is this one, evergreen forest. The second one is the savanna. So, and this, as we have said, this one represents the forest, and while this is the deforested area, because after you deforested, it remains as, or is interpreted as savannas, and then come grasses. Okay, the evergreen forest actually has a water consumption by evapotranspiration of 1500, while the savannas has a water consumption of 1480. That is, let me do my math. That is not huge. Maybe, like, we can refine this by having better polygons on the field, but the evergreen forest consumes 2% more water, according to this tutorial, and according to this to the algorithm, or like the land cover type that we have selected. The media, well, the mean and the median are, I would prefer to use the median, because there are some outliers, some points that are giving high values, and the median won't take those. The grasses are taking less water, like there is a difference in between the forested area, like savanna. There is a places where they can be, it can be a tree or maybe some shrubs and so on. And when there is grasses, it takes less water, like it takes here. Here we have that the forested area takes. Let me give you the right number. %more water. Okay, the urban areas are huge because this is very warm, so like all water will evaporate. And the other ones are really few pixels on our analysis. Okay, so I hope that this tutorial will have shown you which is the procedure to do analysis of the water consumption in between deforested areas and forested areas, and have shown you new capabilities of QGIS to do this analysis. The initial files of these tutorials will be on the description of this of this video, and plus this actual project will be as well on so it will be the initial and the final ones. Please follow us by facebook.com Hatariwater and twitter.com Hatariwater, and I will leave you my email address if you are something were not clear, and maybe we can, or like you have another topic, maybe we can do more another and this is my email, so you can write me, and then we can do some other tutorials maybe for you. Okay, so thank you for following us and subscribe to this YouTube channel as well. Okay, thank you. See you in another tutorial. Bye bye.